Hi, I'm Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is to continue working on our JS Effects library, the library that is going to help you develop better looking, easier to develop real-time audio processors for REAPER. And specifically what we are doing today is we're going to do a follow-up on yesterday's stream. I learned something else about Bezier Curves that I want to fix in our implementation of Bezier Curves drawing. And then we are going to finish the migration of the previous version of the library in which I made some decisions that we changed, mainly naming, but some other things as well. And then there is some leftovers from the previous version, mostly just the demonstration of the colors, and that's what we are going to finish migrating. So let's start with the Bezier Curves. Let me show you what we currently have in terms of that, which is the result of yesterday's stream. Let me come here in REAPER and make sure that everything is muted. And let's drop our demonstration effect that is using the library here. So these are the Bezier curves, linear curves, which are straight lines, and then quadratic curves, and then cubic curves. Now, what I don't like about this implementation is the idea of steps. So you have a curve, and to draw the curve, I need to draw it in line segments. So I need to break it apart. And right now, the way that I'm doing that is I'm asking the developer using the library. I'm asking the person who's calling the function to provide me with the number of steps. So for instance, 10 steps or 20 steps. And if you have enough steps, then the curve is going to look smooth. But if you don't have enough steps, the curve is going to look like a bunch of line segments. And in fact, you can sort of see that here. Let me change the number of steps, and that will make the effect even clearer. So you can start to see the straight lines that are composing this curve. And of course, if I make this more extreme with only 5 steps, then you can clearly see all the line segments composing the Bezier curve. And I didn't really know how to come up with an ideal number of steps that would make the curve smooth every time. So I did some research and I found this cute article that has a solution, and it's a pretty intuitive solution. It's kind of a cute thing. So that's what we're going to implement right now. The thing is, look at how we build the quadratic curve, for instance. There are 3 control points. 2 of them, the starting point and the end point, are in the curve. And then this other control point here is just to determine how curvy the curve will be. More about that in yesterday's stream. But the thing to note here is that the distance or the length of the red line, which is the Bezier curve, the length of the red line will be at most the distance between P0, P1, and P2. It can never be longer than that because the curve in red is never going to go out of these 2 straight lines in gray. And the same is true of cubic curves as well. Even if we have a cubic curve like this, then this red curve cannot be longer than the gray path. So what we are going to do is take the number of steps to be equal to the length of the gray line. And in some cases, that is more than enough. I guess in most cases, probably it's going to be more than enough. So maybe we will do some kind of division or multiplication or adapt the number. And in this article, they actually do that. They use a curve. Funny, right? So yeah, they use this curve to pick the number of steps. So if you have relatively long curves, then you just take that number, to be the number of steps. But if you have a relatively short curve, then you increase the number of steps just ever so slightly so that you will have enough steps to do the thing. And you can see that this line here is the length of the gray line on this drawing. They are actually multiplying by a constant factor here to have enough points to do the line segments. So let's implement this. I believe that the first thing we need is some notion of distance. Yeah, in fact, that reminds me that we need more distance algorithms. For instance, the Manhattan distance, and there are many kinds of distances. We are going to implement one right now, which is the Euclidean distance. So let's go to the part where we implement mathematical functions. So before data structures, that's for sure, but after the hyperbolic functions. So how about that? Distances. And there are different notions of distance. We are going to go with the Euclidean distance. Am I right? Is this the right name for the thing? That is the right thing. Yes. So maybe I will even paste here this Wikipedia article, and then we can look at the formula, but yeah, this formula is rather straightforward. I believe we used this somewhere else, but I forget. In any case, given, I guess in this case they're calling it P1 and P2 and Q1 and Q2, so they're not calling it X and Y. And I'm gonna go with the nomenclature here on Wikipedia. So these are the coordinates P1 and P2, which would be like X and Y of the first point, and then Q1 and Q2, which would be like X and Y of the second point. And then we just return the square root. I can show you the formula while I'm implementing that, but I know this one by heart. All right, so it's the square root of the square of Q1 minus P1 plus the square of Q2 minus P2. So this distance is, for instance, the distance between P0 and P1, for instance. There you go. So that's the kind of distance that we can compute now. How about we also write some tests for this? It doesn't hurt, right? So let's find a test for this and add a couple tests right after that. And then we call this function instead of that one. And then I know that, for instance, the distance between points... Oh, Bo is here. Hey, Bo, great to have you. How are you feeling today? Are you getting better? I hope that you are. So I know that if I have a point at 0, or actually at 2, 0, and 0, 3, that distance should be, no, it's actually 3, 0, and 0, 4, that distance should be 5. That's just the canonical example where you have sort of a triangle going on. There is this geometric intuition for how that formula works, and suppose that this distance is 3 and this distance is 4, then this distance is going to be 5. That's just a Pythagorean theorem. Yeah, there you go, using that. So how about we translate the whole thing so it's not sitting at the origin? We can translate this somewhere else. And we can translate it first on the x-axis. So let's translate it 3 points in the x-axis. Let's translate it maybe 5 points in the y-axis. But the distance should remain the same. And I think that this is the only test I need for this, really. This is such a simple function. So let's run this test. Euclidean pass, great. So now we have the functionality we need to be able to compute the distance. And Bo says that actually, yes, I did. Ah, okay. I couldn't imagine that fasting would help with the kind of thing that you have going on, but I'm glad that it is working for you. All right, so using the Euclidean distance, let's come up with the number of steps. So maybe another thing I could do is write some unit tests for the Bézier stuff that we are coming up with, but I don't know. I mean, it's such a visual thing, and the formulas are so crazy. Yeah, I think I'm going to go with just the visuals, same way that I'm doing with the EQ, right? The EQ is just a bunch of mathematics, so in the EQ I don't have unit tests. I could just run some impulse through an EQ and then register the impulse response and test against that. Static values, these are things called snapshot testing, but I don't really see a point. I think it's better to actually interact with the thing and try it out. Right, so the point that I want to make with the Bézier stuff is that I can get rid of the number of steps. I will calculate that for you. So I removed that argument on the function calls, and then I'm going to visit the implementations. And more specifically, here, these steps parameters, I'm going to remove the steps parameters from all these implementations of the drawing function. But I will need to compute some stuff to compute the increment. So essentially, I guess I am saying that I will compute the number of steps in the function body. And the number of steps is going to be the distance Euclidean of P0 x, P0 y, P1 x, P1 y. And then this is over for that one. But for these other two, I need to add the distance between P1, x and y, and P2. And then that's done, but I still have to do it for the cubic one, I still have to do it. Then it's the distance between P2 and 3. So this should give us a good number of steps. It's probably overshooting, but it should be smooth. Let's try this out. All right, it looks smooth to me, except maybe for this part, but it doesn't look too bad. It does not look too bad. Right, so let's commit what we have, and then we are going to play around with this, trying to come up with something like, trying to come up with something like this. Try to play around with the number of steps to try to get something even smoother. Let's see. And there's also thickness and other things that I want to implement in the Bezier curve. But I think that not having to specify the number of steps and figuring it out myself is a good start. Right, so all these changes make sense. And Bo says, have you published this library to GitHub? No, by the end of today, I'm going to publish it. I have to copy it over to another directory. It's just a thing that I have to do, and I often don't do it. So I have to move it to another directory, and then I will publish it to the usual place that you probably know at this point. So yeah, I pushed 14 days ago. That's the last time I remembered to do it or bothered to do it. But by the end of today, you will be able to play around with the Bezier curves. All right, so we implemented distance. Great. And then let's just play around with this. So I think I'm gonna do this interactively. Well, there's really no easy way for me to do that interactively. So I'm gonna come here and let's play around with the cubic one, which is the most difficult to get right anyway, because it's more curvy. So how about we just multiply this number of steps by 3? We are going to get more steps, which will make the curve smoother. Maybe, hopefully, probably. Let's compare. I don't think it's any smoother. So probably what we are seeing here is not the result of not having enough steps. Probably what we are seeing here, this staircase situation we see here, is probably not an issue related to not having enough steps. It's an issue related to aliasing. We don't have enough pixels to draw here. I mean, we are literally going from one pixel to the next and there is no pixel in between. So could we implement some anti-aliasing features? Maybe. Are we going to? Probably not. But definitely not right now. What if we have fewer steps? Then we should see some staircasing. And we actually don't. So how low can I go here? And this is actually better. So there's something interesting going on. If I have a big number of steps, then I'm asking REAPER to draw many line segments, and the line segments become that ragged aliased thing. But if I ask REAPER to draw fewer steps, then maybe there is like a line that goes from here to here and another line that goes from here to there, and it actually kicks in some anti-aliasing. That's one of the arguments to the drawing function, right? This true is for anti-aliasing. And it actually looks better. I mean, maybe you can tell that there is a point here and a point there. So maybe 0.1 is too drastic. But for our purposes, I think that maybe having fewer steps may be advantageous in some contexts, right? You can see the quadratic curve here is super sharp because I'm not applying the trick of multiplying the number of steps by something. So this is super sharp, but aliased, while the cubic one is not as sharp, but it's anti-aliased. And if you ask me, I think that this looks better. So I think that we are going to turn this number of steps down by multiplying by a factor like this. And it also has another advantage. We are drawing fewer curves or fewer lines, and drawing fewer lines is faster. So yeah, I will make this very prominent by putting the 0.1 in the beginning. And it's going to read like this. And I'm going to take this 0.1 out, and I'm going to make a constant out of this. If you really want, you can get into the internals of the library and you can change this constant. I'm going to call this the smoothing factor. And the greater the smoothing factor, the more, well, the smoothing factor is kind of an interesting thing, because if you increase the smoothing factor, you will have more steps, but it will not necessarily look smoother. It may look more crisp. I would just call this the steps multiplier. And then if people want to change this constant, they are free to, and they need to understand the consequences of that. Right, so let me put that there. Steps multiplier times that, and then over here, steps multiplier times this. And then in that one, it's kind of a boring one. It's just a straight line, so this is kind of overkill, but it is what it is. We are actually using the Bézier formula for a linear interpolation. Take that for what it's worth. Right, okay, so now we can play around with this. Let me commit what I have, and then we can play around with this, and then we can find a value that we like to be the default. Let's calibrate this value. Okay, so maybe 0.1 is not good enough. I can see some of the wonkiness related to that. But I just said that I can, as the user of the library, tweak this multiplier if I want. So anywhere in the code, I can just jump in and start playing with these values, and I can play with this in real time. As I save, it updates this curve. And I cannot see the other one, but maybe if I make the window a little bit bigger, then there it is. So now let's play around with this value. 1 is maybe too much, I would say. 0.5 is almost the same, if not the same. Then 0.3 is okay, almost the same. In 0.2, I think we are reaching a sweet spot. It's not perfect, but it's okay. And then 0.1. Is this making any difference? Am I being fooled by this? How about we make the value super small? Okay, it is making a difference. If I make the value super small, then I can see the straight lines composing the curve. This is not too bad. Okay, I think that 0.1 is too little and 0.2 is too much. 0.13 looks nice. Now, naturally, I'm optimizing this for the specific curves we have on the screen. So it's like not perfect, but I think that the best we've got is yeah, I think that this is the best we get. So 0.13 is our number. All right, cool stuff. Let's move on to the color drawing situation. And Bo says, I had an idea the other day regarding the line thickness. Could you draw circles of different widths along the line? I think you discussed drawing triangles with Justin. Yes, if you wanted to get fancier with this, the problem is REAPER doesn't have features to actually draw thicker lines. So you have to come up with something yourself. And the trick that Justin used in ReQ, at least that's what he mentioned, and the trick that I used on the library here as well, if you want to draw thicker lines, is I just draw a line and then I draw a line 1 pixel away and then 2 pixels away and so forth. And that works. It may not be ideal. So another thing you may want to do is, like Bo is saying, you can draw little circles along the line. And that may work. I'm not going to change the whole code to actually do this, but I also had that idea. I think that maybe circles would not be ideal because circles don't render well with anti-aliasing, especially in small sizes, but rectangles could work. So essentially we are just drawing pixels, but bigger pixels. And if we draw enough of them, it may look okay. It may look weird. I don't know. And then finally, there is the idea of drawing triangles. And yes, there is a JSFX function you can call to draw a triangle, and then you give the coordinates. In fact, if you have more than 3 points, you can just give as many points as you wish. And the drawing thing is going to draw a polygon of the with the points. But I haven't really played around with that. But if we had something like that, we could implement our own anti-aliasing routine. I don't want to get there. And there is actually a limitation of this. You can give as many points as you wish to the drawing function, but you need to know the number of points ahead of time. So in theory, we could find all the points that delimit this curve. And I'm not saying the points on the curve. I'm saying the points after you have some thickness to the curve, you can determine the path that surrounds the curve, the shape. And then maybe you could pass all of them to this polygon function, but it doesn't really work like that because you need to know the number of points you want to pass to the polygon function ahead of time. For more curvy and longer lines, I would need more points. And for straight lines, I may need fewer points, but that's not something that I have control over. So the fix for that in the ReQ implementation, as far as Justin said and I understood, the solution for that is you break apart the thing in sections, like let's say in sections of triangles. So you give the function 3 points at a time, and then you section the area yourself. And that seems like a pain to implement, and we may get there, but definitely not today. And then Bo says, the cool thing would be to have a triangle square of a different color to indicate value. I'm not sure I understand that. Do you mean like in anti-aliasing, where, I mean, we can probably see some anti-aliasing happening here. Yeah, so you can see that some of the blue is darker and some of the blue is lighter. So this is anti-aliasing in action. Is that what you're talking about? Because if it is, then it's something we can do. We can implement an anti-aliasing engine, but I'm not in that business right now. It could be fun. Not saying it wouldn't be fun. I'm just saying I'm gonna move on to colors now. So, and not only colors, everything else that we have going on here in this file. My goal is to finish this file today. It's just 500 lines. I mean, how hard can it be? So let's see what we have. We have some title that appears on the page, and that appears on every page. Cool. So let's migrate this portion. So it's after the background color and after the, well, this is essentially the background as well. And we have a body padding situation going. That's great. And then we start drawing the contents of that page. So I'm going to paste the title situation here. And is title height going to be used elsewhere? Yes, it is. Great. And this is no longer a function, it's just a value. And the name didn't change, did it? No, it's right there. So this is the title height. And we have this convention that all the variables are prefixed with the block where they belong. Is this something that I violated elsewhere? I don't think so. Yeah, I think that this is still all right. So then we print, and maybe the print function changed. The print function is a helper to help you print on the screen, but also to help you remember all the things you have to set, like the font and the color. But I think that this is working. Yeah, it seems fine. We'll try it out. So if I am on the page with tests, well, that has changed. That is the page for Bezier Curves. Otherwise, if my slider page is going to be one of these colors, except that I need to fix the names. And I think I did it. That's that title. Then we have more pages now. Otherwise, if the page is tests, we have to do something. That is going to be tests. Okay, I can detect a pattern. So I'll have circular buffer, RMS, filters by quad, and filters discrete Fourier transform. That cannot be right. That's better. So now we already have the one for tests. Let's just copy all of these guys. And then over here, paste them. Yeah, paste them there. So circular buffer. I think it's circular buffer delay in parentheses. RMS, filters, and discrete Fourier transform. Alrighty. Then let me double check that the parameters are still in the same order. So that's the string that I want to print, and then we have font size, and this is no longer a function. So let's fix all of these guys in one go. So font size, font style, alignment horizontal and vertical, overflow, color, position, and width and height. And you may be wondering, why is the width and height 0 here? Well, that's because we are not trying to center anything, so we are just letting the text area be 0, 0, but then we are saying that, okay, the overflow should be shown. So I just don't care about the size. Great. So now we should see some titles on these pages. All right, Bezier Curves, that's there. And then colors. Of course, I didn't migrate the color pages themselves, but the title is there. And tests. And I suppose that we need to fix the spacing and also fix the color, which is kind of weird. I see milliseconds to samples twice. Oh, I see everything twice and once in white. That is very weird. And then the circular buffer is not showing anymore, but it's actually showing here in white. There's a line there. And then RMS, it's also going to be... Oh, RMS is going to be just silence. There is no audio going through this right now. Filters, this page is actually not going to show much. Or maybe we can use the Fourier transform to show the results of that. And then here is a line showing the results of the discrete Fourier transform. Right. Maybe I should indent this whole thing because it's one argument, this whole conditional. So maybe I should indent it like this. Okay, looking good. Whoops, cancel. Okay, I just removed that part that I migrated. Yeah, let's go over the changes on this more carefully. Okay, and then there, the things we removed. Okay. Bo says, let's say you have a path to indicate a compressor curve, and the value is plotted along the line with a different colored square. Oh, okay, so you want a line that changes color in the middle. Okay, that's interesting. And I don't think that you are just saying that you want to specify a color for the beginning and the end and then interpolate between the colors. No, you want to be able to specify different colors for different values. That's an interesting concept, and I think it will be useful somewhere. So yeah, I will add a to-do for the drawing stuff. And that will be colored lines. I'll call it that. And we do have this linear Bézier curve, which is a silly curve because it is just a straight line, and it right now is aliasing and causing all sorts of distortion problems. You can sort of see how it's a bit of a staircase. That's kind of silly, right? We could just call a function to draw a line, but this implementation may come in handy for the thing you're describing. And also, if we, instead of drawing lines, we do the trick of drawing blobs, maybe rectangles, or just squares, or even circles, maybe, if that works well. In any case, if we draw using these blobs, then I also think that having this function will actually come in handy because it will give us a way of drawing thicker lines without having to draw multiple lines, one on top of the other. Right, so what do we have here? Just that to do. Right, okay, so let's give this a bit more space. It's not rendering right. Oh, I know what the issue is. This variable is now GFX body padding. And everything else I think is all right. So let's try this. All right, that's better. So the title of that section is here. Let's take the chance to actually position these three curves in places that make sense. So I will go to the Bezier Curves page. And I will change these coordinates to be values that make more sense based on our design system, maybe. So this needs to happen at body padding, going up to, well, the body padding is already multiplying by the X retina stuff. So I don't need to do that. And then I will also change this 100 to maybe the body padding. But I need it to be also after the title. So I will add that. And then this goes down to the right, actually. So the padding plus. How about we have some GFX X and GFX Y. Why am I doing this? Because then I will be able to say that I want to go from here to a place that is relative to here, which I think is a better way of reasoning about this. So I want the line to go down by, let's say, 8 spaces, or sorry, to the right by 8 spaces and down by 8 spaces. Neat. And maybe this will have a bit more of a padding. A padding of like 4. And then the whole figure is going to translate further down, just like that. And I also want to have a label for this. So let me grab one of these calls to print and go there and print something. And what I'm going to print more specifically is how more or less you call this function. And then extra small looks okay. How did we do the printing for things that are not titles? We went with extra small. Okay. Oh, no, I'm looking at the wrong place. I wanted to look at the legacy. So let me find instances of print. And we went with extra small. And then here we went with extra small regular. Okay, I'm gonna go with extra small regular left top. Text overflow visible. I don't need to go that dark. And then I want to print at this location. Okay. Well, then in that case, I may want to translate the drawing to the right. So I'm going to do that now. And I'm going to add a label width that I will define here. So GFX label width is going to be a space of like something like 20. So now I have a little component that is label and then translated to the right, the drawing itself. Let's see what this looks like. Okay, it's not bad. I mean, it's overlapping, so I don't have enough space, but other than that, looks all right to me. So now I'm going to just add a bit more space, like maybe 40. And then it's perfectly acceptable. Then I am going to do something very similar. The padding and the width can be like this. And I don't think I need the curve to be in red anymore. I think it can be in black. Or dark gray, but whatever. Let's see what that looks like. Yeah, more sober, more nice. And then of course I also want to remove the colors from these people. And I will want to do something similar to this in these two locations. So the X position I don't want to update, but the Y position I will want to update. And I will update it with plus equals and then some height. That may be something like 20. Okay, I think that this will be enough space. Now let's move these curves further down. So for the quadratic one, I want it to look somewhat like the Wikipedia article. Let me find the Wikipedia article again. So I want it to look somewhat like this. So I want it to be starting and ending more or less at the same point, except for translation of some amount of space, let's say 40. Or even less, like 32 on the x-axis. And I want in the y-axis to give it some space as well. Let's say 10. And then on this one, I want it to be somewhat in the middle. So I'm going to say 16. And this is going to be, I guess, without any space. And there it is. Could be a bit higher, I suppose. So how about I subtract a space of 10? This is going to bend the whole curve upwards. Good. And then finally for this one, I want it to resemble this curve. So the start and end points kind of already make sense to me. And then I just have to turn this P1 from here and split it into P1 and P2. That's what I'm going to do. And this one is going to be how do I do negative spaces? Oh, with an underscore. Okay, whatever. Just wanted to remember. So this is going to be like plus, or actually minus 2. Yeah, minus 2. And this can be at plus 20. I think that does it. Let's look at the curves now. It's not perfect, but it's good enough. This is a good showcase of the Bezier curves. I'm happy. Let's commit this. Take a look at the colors now. So this tests page from the old implementation. Well, actually, let's look at it. The color stuff we are going to look in a moment. Then the tests are super weird, right? So let's look at the tests. Yeah, I don't want to do it this way. I don't want to do it that way. I don't want to do that. So that's why it's printing twice. That's super weird. Why do I have that twice? Why didn't I realize that before? All right, so we are printing the tests with extra small, regular, left, top, visible, padding. Well, I guess I need a bit more padding, so I'm going to put some title height. And that will be that. Okay, that was easy. All right. So that wraps up the tests page. And here we had previously on the old library, we were running the tests on the GFX block. Bad idea, sir. Bad idea. So now the only thing left is the colors page, which is this gigantic thing. But it's mostly copy and paste. So let's get in there. This page is going to be between Bézier and tests. So this is the end of Bézier and the start of tests. Just like this. And then instead of tests, we'll have all this color situation going. Two, three, four, five. And then we have something specific for that page. The first thing that we have is specific to that page is... That was a weird character. How did I type this? Oh no, it's just a letter K. I thought it was some kind of weird arrow. So let's first print this annotation that helps you understand how to actually call a caller. And it's not a function anymore. So it goes like this, and all of these things are not functions anymore. So it goes like that, and then I will have to add some space horizontally so that the thing goes to the right, and these body paddings need to be prefixed. Okay, let's see how that is looking. Yep. That is what I want. Then the rest of this is to actually print the squares and everything. Yeah, let's go over this here on this scratch pad before, and then we can adapt everything, and then we can cut and paste in one place. So I think that most of these function calls are going to be wrong. Let me search for open and close parens and replace with nothing. Yeah, all of these are safe to replace. Those are safe to replace as well. Okay, so we can replace all of them in one pass. That's great. And these are some constants to do the spacing. What we definitely need is some prefix for all these variables. Great. And then I'm going to remove one level of indentation from everywhere. Try to get this as close as possible to something I can cut and paste, and that will work. But I'm not working over there on the other file because I don't want to break it. And I want to do all these global replacements more easily. Then this variable, I want to rename to that. And then that variable, I want to rename to this. Great. Then this. Let's see if it's safe to rename globally. It seems to be. That doesn't look right, and it appears in two places. So maybe I will rename this into that. Oh, and all these occurrences of page need to change as well. This is a slider page. That will not be trivial. So how about I search for space page and replace with space slider page? That will cut some of the replacements we have to make, but maybe not all of them. Oh, I think that does it. Great. This color shade index is definitely something I can rename globally. And then rounded rectangle fill, we need to check how that is called now. I may have changed the way that it works. It receives 4 arguments. Oh yeah, 4 arguments with coordinates. So and a roundness thing. So that didn't change. I think that this may be good to cut and paste, but let's commit first. And let's find the color pages are there. No, where are they? Yes, here. Here is the color page. I want the indentation to look like this, actually. So I'm going to commit this change. Then I'm going to try to paste that code, and we'll see if it will work. All right, let's test this. All right, it's not perfect. It's drawing everything in black, but it's something. At least the labels are right. So let's figure out the color situation. Where are we? Oh, I guess I can remove the other file. Great, all the legacy is gone. Oh, these were functions and they were changing the current color. So what I have to do here is call color with this whole thing as an argument. It's not ideal. I may refactor this in the future, but it will make things work for now. Hopefully, maybe, we'll see. I think that this is gonna work. Let's see. If it works, it works. If it doesn't, then we'll wrap it up anyway. Nope, here we are, colors. Colors are there, great. Let's just fix the space then. Well, to fix the space, I first have to find where we are drawing something. Yay, indeed. Okay, so we are drawing based on this, and we have a body padding, title height, then the body gap. Well, all of these variables have changed, haven't they? That may be the only issue. Great. And now it's time to do what I promised. I'm going to add a folder to the workspace. I am going to find my REAPER repository. And these are the stuff that I'm working on. I will get to more JS effects, brown noise, that will be fun, pink noise, tone generator, kind of already worked on that, and EQ, that is RBJ filters. My first humble implementation of that I never shared with anyone. Great, so I can copy some stuff over. I can copy the demonstration effect, and I can copy the library. Demonstration and library plus commit and push. And there you go. But if you want to go to the GitHub repository, the library will be there. Again, I will not update this in repack because I don't want people actually using this, but you can download and give it a try, and you can play around with the Bézier functions and everything. And with that, I will sign off. Have a great weekend. Thank you very much for being here, Bo, everyone else who's watching this maybe later in the future, everyone who supports me on PayPal and Patreon and who is subscribed to the channel and all that good stuff. Hope you all have a great weekend. Bye.